I was looking through the notes you sent over all these physics papers and maritime charts, and they all seem to come back to this one uh, really quiet moment.
Oh, yeah.
You're standing on a beach, you know, watching a ship sail away.
A classic image. Everyone's seen it.
Right, but I think I've been missing the most important detail. If you really watch, the ship doesn't just shrink into a dot.
No, it doesn't.
The bottom part disappears first. The hull just vanishes, then the deck, and then for a while all you can see is the mast.
And that observation, the hull down effect, that's not some trick of the eye. It's real physical evidence that we're standing on a curve.
So for today's deep dive, our mission is to actually measure that curve. We're going to use some basic geometry from this research to figure out why the horizon is, well, a lot closer than you might think.
It all comes down to a simple right triangle. Just imagine a line from the center of the Earth to you and another one out to the horizon.
And the third line is my line of sight to that horizon point. Okay, so we're talking about the Pythagorean theorem here. The old a squared plus b squared equals c squared.
That's the one. And it basically shows that your viewing distance is tied to the square root of your height.
Which means being a little taller helps, but getting up on a cliff or a hill helps a massive amount.
Exactly.
So let's run the numbers. Based on the data, if I'm on a beach and my eyes are about, say, 1.7 meters off the sand, how far am I actually seeing?
It is surprisingly close. It's only about 4.65 kilometers.
Wait, really? That's barely 3 miles.
That's it.
That feels so counterintuitive. I feel like I'm looking out for 20 miles. So you're saying beyond that 3-mile mark, the ocean is literally bulging up between me and that ship.
Physically, yes. Think of it as a huge, very gentle hill made of water. That bulge is a real obstruction.
You know, talking about using geometry to see what's normally hidden,
Yeah.
it kind of reminds me of how complex problems in business can obscure the right path forward.
That is a perfect transition.
This deep dive is sponsored by Embersilk. If your organization needs help with AI training, automation, or software development, they are the team to talk to.
They're brilliant at uncovering where intelligent agents can really make an impact, whether it's for your business or just for your personal life.
Check them out at embersilk.com for all your AI needs.
So, back to the horizon.
Right, so we have this geometric limit of 3 miles, but what about the atmosphere? I saw a note in here about refraction. Does that change things?
It does, and this is where it gets really interesting. The air isn't a vacuum, you know?
Mm-hmm. It has density.
It has density, and gravity makes the air near the surface denser than the air higher up.
And that change in density bends the light rays.
It does. The light actually bends downward, sort of following the Earth's curve.
Yeah.
We call it standard refraction, and it lets us see just a few % farther than pure geometry would suggest.
Okay, because I see this all the time online. People bring up that 8 inches per mile squared rule.
Ah, yes.
Yeah.
That one.
They use it to argue that certain buildings shouldn't be visible if the Earth were curved, but since we can see them, the whole idea is wrong.
And that is a huge misunderstanding of what that formula is even calculating.
It's not for what an observer sees.
Not at all. The 8 inches rule calculates the drop from a perfectly flat imaginary tangent line sticking straight out from your feet. It completely ignores the fact that your eyes are above the ground.
So it's answering the wrong question.
Totally the wrong question. The proper formulas, which account for an observer's height, show that someone who's, say, 2 meters tall can easily see a 5-meter object from 10 kilometers away. The simple rule gets it wrong every time.
So the math actually works perfectly. You just have to use the right math.
Absolutely. It shows how consistent observation and mathematics really are.
That's amazing. Just by looking carefully and using some simple math, we can measure the planet we're standing on. It feels, I don't know, really optimistic.
Science is about observing the world as it truly is, and we've got the tools to do it.
If you enjoyed this deep dive, please subscribe to Intellectually Curious. And hey, if you can, leave us a 5-star review. It really does help get the word out.
Thanks for tuning in.